Welcome back. We're going to look next at finding the term for ordinary simple annuities. It's just a common question we tend to get in finance, isn't it? How long will it take to pay off my loan if I make a payment of $500 a month, for example? Or how long will it take to save up for retirement if I can afford to deposit a certain amount every month? When we're doing questions like that, it means that we're solving for the term or for the amount of time, which means we're solving for n. If you remember from earlier in the course when we tried to solve for n was the exponent, and that meant we had to move into logarithms, and that's what we're going to do next with our annuity formulas. If you know the future value that you want to achieve, we're going to rearrange the future value formula to solve for n, and it ends up looking like this if we work our way through. N is a log of 1 plus I times FV over payment divided by the log of 1 plus I. If, on the other hand, you know the present value, you end up with this formula. N is equal to the negative log of 1 minus I times present value over payment divided by the log of 1 plus I. Notice there's a little negative sign there. That doesn't mean anything too special. In fact, if you left it out, you just get a negative number for an answer, and a negative is a positive, so you just remember to make that positive before you write it down. Let's go ahead and try these guys out and give you a sense for how they work, because they're a little more complicated than what we've used so far. But just like with payments, you can see that there's two versions depending upon whether you know the future value or the present value. Eric wants to retire with $500,000. That's a great goal. How long will it take to accumulate this amount if he deposits $200 per month into a retirement savings plan, earning 6%? That's it. That's the question. Well, let's write a few of these things down. He wants to have $500,000 in the future, so it's a future value amount. He's going to make deposits of $200 per month. The interest rate per month is 0.005. How long will it take until he has enough money, or until he's got his total saved? Since we're dealing with future value, it's going to be this version of the formula. On the numerator, we have the log of 1 plus I times future value over payment divided by the log of 1 plus I. Let's put some numbers in there to see what it looks like. That's 1 plus 0.005 times 500,000 over $200. That's his monthly deposit. And divide it by 1.005 in this case. We'll go ahead and plug those numbers in there. We end up with 521.8 as a value for n. Well, 521.8 what? Well, we have to go back to look at our compounding to figure that out. Since we're doing monthly compounding, that must be months. Now, you might be tempted to leave it there, but really in finance, our typical way that we do things is we try to make things easier for people to understand. And if you went up to someone and said 521.8 months, they'd have really no idea how long that was. But instead, if we convert that over, and how do I convert months to years? Well, I divide by 12. I'm going to end up with 43.5 years, roughly. That's easier for someone to understand. So if Eric is now 20 years old, he'll be 63.5 when he can afford to retire. If you're a little alarmed by that, that seems like it's too long away, well, you could increase the amount you deposit per month. You could increase the rate that you go for, or you could decrease the amount of future value that you're trying to save. Let's have a look at another example now. Leah borrowed $18,000, plans to pay it off with payments of $500 a month for as long as it takes. How long will it take? If she gets charged interest of 8% on her loan, well, let's write a few things down here. That $18,000 I'm going to call the present value because that's what she's just borrowed, so it's in the present. So we're going to be working with the other formula this time, aren't we? Now for I, it's 0.08 over 12. That gives me one of those repeating decimals, doesn't it? 0.00666666, or sometimes you'll see it written this way, 0.006 repeating. It's very important we keep all the decimals for that, isn't it? And we want to find n. So what's n going to be? Well, we're going to use this version of the formula, 1 minus I times PV over payment divided by the log of 1 plus I. Let's put some numbers in there. Negative log of 1 minus, I'm going to write the full fraction for I, do the calculation rate in my calculator to keep all the decimals. It's going to give me the most accuracy, times 18,000 over $500 payment, and divide the whole thing by the log of 1 plus I. Go ahead and plug that in my calculator, and I get that n is equal to 41.30. And again, 41.30 what? Well, in this case, it's months as well. We just have to look at the rate for that. You might find it's better to divide that by 12 to give me something in years, and that's 3.44 years. Again, that might be easier for someone to understand. So there we go. There's one more example. Let me give you one to try out now. Robin buys a new sports car, costing $60,000, and he takes out a loan at 3%. How long will it take to pay off this car loan if he sets his monthly payments to $1,000? So he's going to pay $1,000 at the end of each month for as long as it takes. How long will it take to have this work out? I'm going to suggest you hit pause now for a minute. Take some time, work this one through, see if you can come up with an answer. Work your answer out and then convert it to years as well, to 2 decimals when you get to the very end. And when you're all ready, come on back, hit play, and I'll work through it with you. All right, let's have a look. So Robin bought a car that cost $60,000. That's the value in today's dollars, isn't it? So that's the present value. The interest rate per period, 0.0025. He's going to set his payment to a nice round $1,000. How long will that take? Well, I'm going to use the PV version of this formula because I've got 60,000 as a PV. That's 1 minus 0.0025 times the 60,000 divided by 1,000, all divided by the log of 1.0025. As I worked that one through there, I got 65.09 periods, which in this case are months. And then, again, if we want to get that to years, we'll divide by 12, 5.42 years. You may be thinking, how can he make, 65 payments and then a 0.09 payment? That just means that when he gets to the 65th month, he'll pay $1,000, but then the next month, he's really only going to pay probably just under $100, 0.09 left over at that point. It's not quite linear because remember we have compound interest, but it'll be about just under $100 left over in his 66th month. So that's how it works out for Robin. All right. We'll talk more about those final payments and what this all means when we get to a little bit further along in the course. That's it for now. Work through a bunch of these, just like always. Go to your textbook, learn all the different ways they can be worded and that sort of thing. And practice makes perfect, of course. And then when you're ready, come on back and we'll move on to our final topic for this chapter, solving for the interest rate.